In this video, we're looking at algebraic expressions. In algebraic expressions, we use variables. Variable is a symbol, usually a letter, A, B, C, X, Y, Z, and etc., and it represents a number. In the entirety, algebraic expression is a collection of numbers, variables, and operations that we know. But we will never observe things like less than, greater than, or similar in the expression. When we work with expressions, first of all, we can create algebraic expressions, and it usually comes from word problems or mathematical statements that are written in words. And then we use symbols to create expressions. Then we can simplify expressions. And finally, we can evaluate whatever we have as an expression for a given value of variable or variables if we have a few of those. So let's start with the easiest part, and that's simplifying algebraic expressions. In order to simplify algebraic expressions, some vocabulary that can help us tells us that the word term or terms in the expression indicates pieces or elements of the expression, and they are connected with the plus or minus signs. Also, the idea of like terms is used to simplify algebraic expressions, also known as similar terms. This is when we look at the expression, compare things that we see, and that's very likely going to be our variables, but they should be raised to the same power. That's the only way we can combine those things. And finally, to combine like terms or similar terms, such as subtract them or add them, we look at the coefficients, the numbers in front of the variables that we compared, and their powers. And at the end, we're going to get the result that the most simple and has fewer components or terms compared to the beginning of the example. And just note, coefficient will be a word describing a number in front of every term. So let's practice a little bit. For the first example, we have variable x, so that's the same name, and the power is identical for those x values, so that's square, which is a clear clue that we can combine these terms and we can call them like terms. Now, coefficients in this case are positive 6, then plus sign, and positive 7. So all we need to do is combine this number 6 and 7 using addition, like we would normally combine objects, like 6 apples and 7 apples, 6 houses and 7 houses. But in this case, instead of objects, we have algebraic name of variable x squared. So that's our first example done, and it is 13. And since we combined x squared, we're going to keep that value as well. It's not houses, it's not cars, it's not apples, it's x squared. Let's do one more. This time we have two variables, but when we look at them, they are organized x, y with the same exponent, which is 1, and we usually don't write exponent 1, so they look alike. Unfortunately, they are using different signs. So one is positive 19 and another one is negative 30. So when we combine those terms, we need to take 19 minus 30. And when we combine things in which number with a minus is larger, so 30 is more than 19, the final result will be with a minus sign. And we always keep the variables or a group of variables, in this case x and y, in the result. So all in all, we have negative 11 xy. This one is kind of similar to the middle, but we have different exponents or different powers. So we have the same set of variables x and y, but this time x in the first term has degree 1 and y has degree 2. Now in the second term, or the second part of this expression, the exponents or powers change their location. So they no longer look identical to the first part or first term of the expression, which is something that stops us from doing any other movement or steps in terms of combining like terms, because these are not alike due to the different powers. So we cannot combine anything in here. Now, sometimes when you simplify the expression, you have something else in the given assignment, such as parentheses. So for this example, I have minus sign in front of a long expression. So I need to simplify that first so I can clearly see the sign without any variables in front of each term. So if we open up the parentheses, we're going to get negative in front of 5, negative in front of 4, and then the rest of the expression will keep us with positive 4z and negative 8x squared y. Now, if we look at this 1, 2, 3, 4 terms, they are somewhat similar to each other, but not all of them are completely identical. So in the middle, we have positive 4z and we have negative 4z. We have the same name of a variable, but the coefficients are exactly opposite. So 4 minus 4 is 0. So we're going to have 0z in the assignment. When you have something like that, you don't write the variable that in some case you can say it disappears. Now the other group, so we have x squared y, and then we have x squared y. So there is a matching thing going on between the variables, and there is a correct location of all the powers. So we have x squared and y to the degree 1, x squared and y with the power 1. So that matches. Now we're going to combine the coefficients. So we're going to combine negative 8 and negative 5. They both have negative signs, so we're going to combine them together and keep the minus in the assignment. So all in all, it's negative 13. And we combine variables x squared y, so we're going to keep those variables in the assignment. Now to the second option, working with the expressions, and that's called evaluating the algebraic expression. When we say evaluating, or we have an example to evaluate expression, it means take the given value as a number and substitute it in every place where you have a corresponding variable or a letter. And then simplify using something that we know as order of operations, or in short, PEMDAS. For instance, we have long expression with 3 terms. They are not alike, so not similar, because there are different variables in here, and the last number doesn't even have variable next to it. But we're going to evaluate by substituting the x value as number 2 and y value as number 4. So if we rewrite, that's going to look like 3 times 2 squared. So instead of x, we plugged in 2, and then 2 times y. So instead of y, we plugged in 4. Just in case, we wrote parentheses because for the first part of the expression, we need to apply square. And sometimes if you have negative numbers, the parentheses help a lot. Now we're going to follow order of operations, or PEMDAS, and simplify this new assignment that has no variables and involves only numbers. So first of all, we're going to look at the power, apply it, and multiplication. So that's 3 times 2 squared is 4, and then 2 times 4 is 8. Now, following the order of operations, we need to simplify 3 times 4. So that's 12 minus 8 plus 5. Now we have no parentheses, which tells us that we're going to move from left to right and combine elements in pairs. So that's 12 minus 8. So that's 4. And then 4 plus 5 is 9. So the final answer is 9 for this example when we evaluated the algebraic expression. A few more examples to consider. Now this one has only one variable, and we need to substitute number 8 for that spot of x value. So now, following the order of operations, we multiply 5 and 8, which is 40, and then subtract 2, and that's 38. And another one, we have value of variable a, but once again, we cannot combine anything in the expression because one spot gives us a squared, so that's power 2. And another spot or term gives us a to the power 1. So no way we can combine them. They are way too different. We're going to plug in -4. Now we will be careful because -4 has a minus sign. So when we apply certain exponents or powers, it will change its behavior. Anyways, we have 3 times -4 all squared. So as you can see, we use parentheses to help us out and tell us that we have -4 completely squared. And then 2 times -4, again with parentheses because minus everything affecting whatever we do in the example. Now, if we follow order of operations, we have to apply power first, so that makes -4 squared, -4 times -4, so that's 16. And then -4 times +2, so that is -8, because when we multiply positive sign by negative sign, it gives us negative, but we still need to do the addition. And then when we multiply 3 and 16, then subtract 8 and add 4, you can stop and practice that a little bit on a piece of paper or your calculator. All in all, we will get a 44 as the answer. And finally, we're going to look at things that are related to translation from English into the algebra. This is a very quick overview of basic examples. There are more detailed examples provided in separate videos and demonstrations. In the example 1, we have a statement. It has no mathematical symbols yet, but we're going to be translating that into the numbers that we know and symbols that we learned, which is addition, subtraction, multiplication, division, and parentheses. So if we look at this example and read it, we already observe that 5 is a number, 9 is a number. The word times will be translated as a dot or multiplication, and the word sum is addition sign. Now the word number indicates that there is something that we can introduce as a variable to make it an expression. And we can use the letter N or letter X if we have no restrictions in the example. So I'm going to use letter N so that it is short from the number. All in all, I need to take 5, then multiply by parentheses of addition between N and 9. And here how it looks like. Nice and short. So 5, multiplication sign, and since we're adding multiple elements, we put them in parentheses. So something unknown, the sum, which is addition, and number 9. Let's do a little more when some algebra is involved. Again, we have a little clue in this example because numbers are not written as words, and that will help us a little bit. So the sum is addition of 2 and then 3 times. Okay, so this is a multiplication, but 3 is a number, so we're going to translate it as a number. And then the word number, as we already know, is a variable that we can use as a letter N or X, and then 4 times a number. So that's very similar to 3 times a number, but instead of 3, we're going to use 4. So let's call unknown number N and translate everything that we have in here. So we have the sum of 2, so that's 2, and then the sum of the rest of the elements. Since we have no special multiplication compared to example 1, we just use the addition symbol. So 3 times the number, so 3 times n, plus -9. Since we are given -9 with a minus, we're going to put it in parentheses to avoid any mix-ups. And finally, 4 times a number. Now, there are some elements in here that look alike. So in order to make the step that we called simplifying the expression, we're going to rearrange our elements. So we have one group of elements, 3n and 4n, that do have the same variable next to them, and it's raised to the same power. So these look alike. Also, we have 2 as a number and -9. So these elements also, or terms, look alike, even though they have no variable next to them, and that's what makes them look alike. Absence of variable. Now 3 and 4 is 7n, and 2 and -9 is -7. So that's a complete translation of our example into the mathematical statement and even using the step to simplify that. And another example that's more applicational, something that you can see and touch in your everyday life. So we have a person who has certain number of nickels, which is N, and certain number of dimes, which is D. In this assignment, we're speaking about American money. So when we look at our knowledge about nickels and dimes, we know that every nickel is 5 cents worth and every dime is 10 cents. Now, if we combine that knowledge, we're going to get the expression that says 5 times N, because we have N as number of nickels and each one is 5. And then we have D amount of dimes, and each dime is 10 cents as a value. So the phrase that we have in the example will be represented by the expression 5 times N plus 10 times D. So as long as we know how many nickels and dimes Russ has in his hands, we know his budget. And finally, another applicational problem, but this time we can use geometry or visual representation of what is written in the assignment. So we have a perimeter of rectangle, which is a figure with 4 sides. It is represented as a statement or an expression for the length as 3x and for the width as 2x plus 1. We don't know and we don't need to know what the x value is at this point. Our goal is to make this long description of perimeter of rectangle into a nice small formula or expression that we usually see for the perimeter. What will help us is a little sketch. So when we look at the rectangle, we know that it has 2 sides that are equal in length and 2 sides that are equal in width. So whatever we have for every length and every width, we need to double. And we also know that for the perimeter of any figure, all we need to do is add up all the sides that we have. So we're going to be adding 2 length and 2 width with the given measurements from the assignment. So we're going to multiply every length and every width by 2. So 2 times length plus 2 times width. So that will help to connect your visual idea of rectangle and its perimeter with the expression that we can expect from this problem. So finally, we substitute the length as 3x and the width as 2x plus 1. But since we observed that we have 2 of each, and we're going to do addition to fix the perimeter idea, that will be our statement or expression. Now we need to simplify that so that all like terms are combined. So for the first term, all we need to do is multiply 2 times 3. For the second term, we need to do something that's called open up the parentheses. So that means taking the outside coefficient, and that's 2, and multiplying it by every element inside of the parentheses. So that's going to bring us to the 6x plus 4x plus 2. There are only 2 terms or elements that look alike in this expression, and that's 6x and 4x. So finally, if we combine them, the expression for the given rectangle and its perimeter will be 10x plus 2. As long as we know what x is, we will know how large or small the given rectangle is.